All right, guys. So if you'll remember, if you have two complex numbers and you're going to multiply them together, okay, then we said the format was R2 or R1 times R2, and then we had cosine of A plus B plus I sine A plus B. Right? Y'all remember that vaguely? All right. So to divide Z1 over Z2, we're going to use this formula. R1 over R2, but then you're going to do cosine of A minus B plus I sine A minus B. No. A minus B, A minus B plus I sine A minus B. I'll give you an example. So in this case, we're given that Z1 is this, and we're given that Z2 is this. So R1 in this case is 30 root 3. R2 in this case is 5. Okay. All right. Then I guess we could say our A is going to be 19 pi over 12, and our B angle is 5 pi over 4, which, since we're going to be adding it, I'm going to go ahead and turn this into something over 12. So it'll make it 15 pi over 12. Just multiplying by 3 and 3. 3 in the numerator, 3 in the denominator. Now I'm going to put it all together. Put it all together. Bless you. All right, so check this out. We're going to have 30 root 3 over 5. Okay, that's just R1 over R2. And then cosine of A minus B. So A is 19 pi over 12 minus 15 pi over 12. Like that. Plus I sine, you get the idea. It's the exact same thing. Minus 15 pi over 12. Boom. Okay. So now what we're going to do is put it all together. So we get 6 root 3. 30 divided by 5 is 6. And then 15, let's see, 19 pi over 12 minus 15 pi over 12 gives me 4 pi over 12. Does this thing reduce? Yes, it does, to pi over 3. So I've got cosine pi over 3 plus I sine pi over 3. And this is it. So now we type in and make sure that we're actually right. So I'm gonna do 6 square root 3. And by the way, the shortcut for pi is just pi. Cosine pi over 3. Ooh, that's not what I want to do. Put it in parentheses here. Pi over 3 plus, bless you, plus I sine. Yeah, what did I do wrong? R1 R2 plus A minus B. 4 over 12 is pi over 3. Hmm? If tangent's undefined, isn't that 90 degrees or 270? Express the result of okay. I figure out what did I do wrong. Oh. All right, so I was right, but they wanted me to put it back into rectangular form. Huh? So no, okay, it's not that bad. It's really not. All right, so we had 6√3, and then we had cosine. This is a problem when you don't read, right? Cosine plus I sine pi over 3. All right, so cosine of pi over 3 is what? If we look at the unit circle. Yeah, so 60 degrees. So cosine of 60 degrees is 1/2 plus I √3 over 2. And you got 6√3 times that. All right, so you end up with 3√3 plus 6√3 times 1/2. And then 6√3 times √3 over 2. Basically, you got, so if you do 6√3 times √3 over 2, basically what you're going to have is 6 over 2 times √3 times √3. 6 over 2 is 3. √3 times √3 is 3. So the answer is 9. Hey, that's how they got that. See, I told y'all it wasn't that bad. Wow. We've done way worse. We've done way worse. All right. Yes, that's what I was thinking. I mean, you can try it on your own, but I'm going to do another example. If you want to try your own problem. All right. So I'm going to give myself a little bit more space here. All right. So we've got, in this case, I'm just going to write out different things. So R1 in this case is 12. R2 in this case is 2. Our our first angle is 13 pi over 8. And our second angle is 11 pi over 8. So what I'm going to do is, because I don't want to write it over and over again, I'm just going to go ahead and write a minus b, since I know I'm going to need it. So it's going to be 13 pi over 8 minus 11 pi over 8, which gives me 2 pi over 8, which is pi over 4. I just reduced my head. So now we're going to write out, I'm just going to go ahead and rewrite the formula here. We got R1 over R2, and then cosine A minus B plus I sine of A minus B. I don't like that color. I'm going to change the color. All right. So we're going to plug everything in. Basically, I got 12 over 2 cosine of pi over 4 plus I sine of pi over 4. I'm gonna pause right there. I just want to make sure everybody's got it, because I know I kind of went fast, but yes. Yep. When you're multiplying, yeah, you multiply. When you're multiplying two complex numbers, you multiply the r's and add the angles. If you're dividing, you divide the r's and subtract the angles. Yes, this plus doesn't change. The only thing, yeah, the formula for multiplication is R1, R2 cosine A plus B plus I sine A plus B. That would be for multiplication. Yeah. All right, so let's finish this up. So I just want to make sure everybody understands how we got here. We figured out what R was, R2 was, A was, B was. Since we are dividing, I already knew I was going to need A minus B, so that's what I did over here. Just did 13 minus 11, which is 2. 2 over 8 is 1 over 4. So that's how I got pi over 4. Bless you. Now, cosine of pi over 4 is root 2 over 2. And sine of pi over 4 is also root 2 over 2. And of course, 12 over 2 is just 6. So now all I got to do is multiply this out. 6 divided by 2 is 3. So that gives me 3 root 2 plus 3 root 2 and that's it. I will. And also, before noon, I think didn't I make this due Tuesday? I think. Yeah, I made it due on Wednesday. So it's not like, I mean, y'all, we're not going to be here Monday. You know what I'm saying? So you're going to have time to work through, or Tuesday. Yeah, I'm going to be here Tuesday. I'm not going to be here Monday. That's why I'd be forgetting. All right, guys. When you are putting this in, so let me make a note of this real quick. Shh. When you're putting this in, write 3i root 2. The reason why you put the I in front is to make sure that the I is not under the square root. Does that make sense? So do 3i root 2, not 3 root 2i. Because trust me, a lot of people do that and get it wrong. All right, let's see if we are correct. And we are. That would have been messed up if I was wrong. Go from basically from here to here. All right, so basically all you do is I multiplied the 6 out. They did a little differently, but I multiplied the 6 out first, just distribute. Then I changed cosine to root 2 over 2. Same thing for sine. I changed it to root 2 over 2. And then you get that. Or actually, hold on. Let me hit undo. You actually see what I did. I just distributed the 6 out. This is all I did. So I do it a little differently than they do it. I don't do it separately. I just went ahead and changed these and then multiply the 6 out. All right. Any other questions? We got time. All right. Last thing I want to cover today. DeMoivre's theorem. DeMoivre's theorem. So many people get this guy's name wrong. They say DeMoivre's theorem, DM's theorem. We can use DM's theorem, DeMoivre's theorem. But you have to think it's a French dude, right? So like the first part is DE would be duh. And then think about like moi, like me, you know, in French, moi. And in French, VRE means vrai, like chèvre or le Louvre. All of that is vrai. So if you put it all together, it's DeMoivre. DeMoivre. Oui. I haven't spoken for so long. It's ridiculous. D'accord, les enfants. Étudie, 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 étudie. Maintenant, je suis. Non, je suis playing. Maintenant, nous sommes. I'm just playing. All right. So what we're gonna do is I'm gonna tell you what DeMoivre's theorem is, and here's what it is. Basically, we're just gonna say D's theorem, okay? I don't want to mess y'all up, but basically, like, never mind. All right, y'all not gonna make me say it. All right, so D's theorem basically said this. Hey, if R1 times R2 times cosine of A plus B plus I sine of A plus B, if this works, what would happen, say, if I wanted Z squared? Well, basically what would happen is I would just have my R1. So if you have Z squared, that's Z times Z, right? So basically what you would have is R times R, and then cosine of whatever your theta was, plus theta, plus I sine theta plus theta. Does that make sense? Because if you're squaring it, okay, I'll explain what I'm talking about. If Z is this, R times cosine theta plus I sine theta, right? If you're squaring it, then you're multiplying it by itself. Therefore, R1 is just R, R2 is just R, A is theta, B is theta, A is theta, and B is theta. So all I did was just replace it with R, R, theta, 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 theta. Does that make a little bit more sense? Just squaring something is like multiplying it by itself. So then what D said was, hey, this is basically R squared and then cosine of 2 theta plus I sine of 2 theta. Is basically what he said. But he said, okay, well, what if I want to take this complex number and cube it? Well, then he turns out and found that, hey, this will be R cubed times cosine of 3 theta plus I sine of 3 theta. So there was a pattern that emerged. And what a pattern do you all can you kind of guess from here? Right. So if I had Z to the nth power, that would be what in this case? R to the nth power and then cosine. Yes. That is DeMoivre's theorem. DeMoivre. This is D's theorem. All right. But that is D's theorem. I know. This is DM's theorem. Because every time I say that, it's gonna be. All right, everybody cool with that? All right, so let's do problem. This problem right here. It says calculate the square root of 6 cosine. Oh, y'all can't see that. It says the square root of 6 cosine 3 pi over 2 plus I sine 3 pi over 2. And we take this whole thing to the 6th power. All right, so I'm write it down because I'm gonna walk you through it. I promise. I ain't gonna leave y'all hanging. I'm gonna explain everything that I do here. All right, so check this out. We're gonna do R to the 6th in this case. So we're gonna do square root of 6 to the 6th power. That's the first part of DeMoivre's theorem. Then we're going to do cosine n theta. So cosine, bless you, of 6 times 3 pi over 2 in theta. Your n, of course, is how many your exponent, basically, how many times you're multiplying it by itself. Plus I sine in theta, so 6 times 3 pi over 2. And we're going to multiply all this out. I'm going to pause right there. I want to make sure you got every piece. If I do square root of 6 to the 6th, what number is that going to end up being? That is correct. But you can check it. I mean, it's just 6 cubed, right? Right. Because root 6 times root 6 is 6. So there'd be 3 sets of those. So it'd be 6 squared, 6 cubed. So it's 216. Just put it in your calculator. Just put it in your calculator. All right. Let's see. 6 divided by 2 is 3. 3 times 3 is 9. So this would be cosine of 9 pi plus I sine of 9 pi. Now, there's a problem here. We're told that our argument has between 0 and 2 pi. So how can we make this 9 pi between 0 and 2 pi? Because 9 pi is too big. Yeah, subtract a multiple of 2 pi. Which multiple of 2 pi should we probably subtract? 8. Exactly. Right, exactly. You just subtract off 8 pi. Because remember, multiples of 2 pi are full rotations. If you just subtract multiples of those off, you're just, that's 4 rotations. You just taking that off. So basically, you're going to get 216 cosine of pi plus I sine of pi. And that's it. So we're going to do that. 216 cosine of pi, and hopefully this is correct. Yay. All right, but then you see DM's theorem right here. All right, are we done? No, we got nth roots left. All right, so I guess that's what we'll do at the beginning of next week. But you all have plenty of time to get through the rest of this stuff, all the way down to here. And that's where I expect you to be. If you are stuck, just shoot me an email. I will email you back. And I do need to, that reminds me, I need to make sure I post these videos as well.